Hello and welcome to yet another interesting conversation from our series of conversations with people from software development. I'm Alex Bolboaca and I'm once again coming to you from the Mosaic Work Studios after being around a few locations that you've seen on video for the past few months. And my guest today is someone I appreciate a lot. He's a speaker at international conferences, at many high-profile conferences, has done work in security, has done work in C++, and he is working on a internet browser which fascinates me for a reason I don't understand. I think it's probably right now one of the coolest things you can do in software development. Welcome, Patricia Aas.
Thank you so much. Thank you for having me.
So I like to start by asking my guests, what is your story? How you got into programming? How did you start programming and why? What made it so interesting for you?
I didn't actually know that programming was fun. I thought programming was boring. But looking at it from the outside, it looked like it was very complicated and things like that. I was really into math. I really liked math a lot, basically since I was a kid. So it was my favorite subject. So when I started at university, I was basically thinking I was going to be studying math. And maybe do some languages on the side because I was excited about languages as well. And after taking, I think, one semester of math, I wasn't that excited about it anymore for some reason. And my mother, actually, she was working at the university, and she said there's this course. It's called symbolic programming, and it is like, it seems to be like something about languages and something. And so maybe you should go try that out. Maybe that is like the intersection of languages and math, and that will, resonate with you. And so I took this symbolic programming course, and it was in Scheme, so it was a Lisp dialect, so it was a functional programming. And this was basically like the infancy of natural language processing. So it was a lot about using Lisp-like languages to analyze natural languages. And my first assignment was like super silly. I think it was like adding two numbers together without actually using like a plus operator, but having to do it yourself. And I found it absolutely super fascinating. Like, I thought it was so much fun. I just went above and beyond anything in the assignment. And my teacher's assistant that was going to correct my assignment, she sent me an email after I sent it in. She said, Patricia, okay, just wait until next week and we'll teach you looping constructs, because I was just copy pasting things. And I was like, this is amazing. So basically I fell in love with it the way I had with math before. That it was like everything I loved about math, just better. And at the end, you had a thing that did something. It's like before I would reach an answer and I could, say, this is the answer, I've done the math. But now the answer, which was the program, it actually did something. And that I thought was super exciting. So I switched to computer science. I took every single programming course that they had at the university. And I haven't looked back since. I still love programming.
So you started with Scheme, but then you switched to C++ at some point.
Oh yeah, we didn't have C++ at the university. But we had a bunch of different languages, and we had some C. We had an operating systems course and low-level programming. While I was at university, my favorite browser was Opera, and we had it running on the Solaris machines that we had at the university, because this was way back when, in the beginning of time. And I really loved Opera. it became like my favorite browser. At the time, there wasn't a lot. This was back in the early 2000s. There weren't a lot of browsers to choose from, and I really liked Opera a lot. And it was also a Norwegian company, so I was like, when I finished university, when I finished my master's, I want to go work at Opera. And so I applied there, and they sent me a programming test in C++, and you know, I did it as best as I could. I sent it back in. They called me in for an interview, and sitting at the interview, one of the guys that were interviewing me said, "So, Patricia, you know C++?" And I said, "No." It's like the first and only C++ program I've written in my entire life I sent to you as your programming test. And they were like, and they just kind of all looked at each other and go like, so what do you know? And I was like, well, I you know, I know Java, I know some C. And they kind of looked at each other and go like, yeah, that will work. It was so basically they hired me with my little C experience and some Java experience, and just threw me in at the deep end, giving me a CVS password and say go make things. And it was a harsh learning curve. It was I made all the mistakes, all of them. It was a pretty painful first 6 months, but they didn't fire me, so I was happy. And I was surrounded by super smart people who knew a lot of things, and so basically I just spent the entire time learning as much as I could. So it was really fun.
So the general wisdom is that math is closer to functional programming than it is to whatever C++ is now, which is a mesh of every programming paradigm that exists. Was it easier for you to get, or was functional programming closer to what you are used to than when you had to learn C++? Did you have to switch your mindset a bit to understand the language?
My biggest switch was when I went from, because I did like 3 classes in symbolic programming, so I was basically programming only functionally, and then when I switched to computer science, their main language was Java. So I had to switch from Scheme Lisp basically to Java. And that was a big change, very different programming paradigm. And I remember like at the end of like my first my course in Java, there was a question like, how would you solve this problem? And the professor said, you know, I know it's out of scope for this course, but you know, and I just like, so I put up my hand and I was like, I don't know if you people have recursion in Java, but I would solve it with recursion. So that's basically when, you know, when I had to do the mind shift. But it was the thing that made me want to go and program more in imperative languages was because I wanted to make stuff. And I looked around and nothing was made from Lisp. Like it's like, I wanted to make things that people used. I wanted to make programs that had value in the real world for people. And I didn't see much example of doing that purely functionally. And so then I was like, okay, then I will learn the programming languages that I need to make the stuff that I want to make. And so I basically, I think by the time I was finished at university, I had programmed in probably 10 or 15 different languages.
Wow. Yeah, well, that sounds really cool. And it's actually quite unique because most of the people we talk with and most programmers have started with imperative languages and then try to very hard to understand how functional programming works. And I think you are one of the few people, well, the only one I know who started with functional programming and went the other way. It's
Oh, yeah. No, it was but now I kind of want to go back again, like just do the loop, go back again. And you do see some of these functional aspects coming into modern C++ as well. still, it's not as natural maybe as it is in functional languages, like pure functional languages, but still it's getting there, and I think it will make for interesting code in the future.
Yeah, I think so. Okay, so you were working on Opera, and you worked on I think another browser, right?
Yeah, the Vivaldi browser.
Okay.
Yes. Yeah.
What were your main challenges in that context? I'm just curious about browsers in general. They seem to become very complex. They seem to be like the operating system of the internet now.
Yeah.
And
they are, and I think that's why I find them so interesting, because everything in computer science that you might find fascinating, there will be some of that in browsers. So it becomes a product that kind of encompasses all the things, which means it's huge, right? They're massive things, but at the same time, really fascinating in that you can learn basically anything. And so I think the only other thing, like you said, that has that kind of space is the operating systems, which I also find are very fascinating. So I always kind of wanted to work like in that area, and I think that's also why I am a C++ programmer, because the things that I like to build are written in C or in C++. And now some of them are starting to be written in Rust, which means that I need to up my Rust game.
Right. And yeah, I know there's a lot, and I've been watching browsers for a while now, of course. And it struck me at one point that they became this operating system of the internet, because now we are running applications on top of them. You can install applications. They have a file system. They have fundamentally everything. Almost everything that you learn about in operating systems has now turned into browsers. And I know you're also building yet another browser, so that should be an interesting story as well.
Yeah, no, I don't know why I did. I think I wrote a blog post. I should probably read my own blog post. No, the thing is, I find them super fascinating, I have to say, and I think my dream would probably be to run, like, if I could like choose my career for the rest of my life, it would be like build browser for the rest of my life. But unfortunately, it is a very difficult, like one thing is like technologically, like if given unlimited funds, I could probably be able to recruit the people I would need to like build basically a browser from scratch if needed. The problem is the unlimited funds. Browsers have a lousy business model, and especially for the bring up of browsers, because currently, like, what the big business model of basically all browsers is search. So you basically make a deal with Google, and Google will pay you, and Google pays you usually per user, which is in a way, it's a very scalable business model. You more users, you get more money. But there's no way to get from zero to your first Google deal. Like, there's nothing there. And so you haven't seen a lot of that happening lately. Like, most new browsers are either funded by existing companies or by people who are like super rich, or people who've been running browser companies forever. So it's not a great business. But it doesn't mean it's not fun. So trying to combine sustainability with building a browser is sort of what I hope to accomplish, though I'm not there yet.
Okay, so for the people in the audience, who are probably most of us, who don't know anything about how to build a browser, Where do you start technically, if we ignore for a moment the business aspects?
Well, they like today, most of the modern browsers are based on what is called it's an open source project called Chromium, and basically what is now referred to as Chromium Blink, which is Chromium. And this was a fork that Google did many years ago of WebKit, which it powers Safari, which again itself was a fork from KDE's Conqueror codebase, or that part. So this codebase goes back a long time. But yeah, so most browsers are based on this, and that means Chrome is, Opera is, the new Opera is, the new Edge is also based on this. Vivaldi, where I worked, also Brave, and it basically contains all the things. So if you just like download and build it, which is like a massive process, then you basically it starts up as a browser. So you can basically customize it from there. But that wasn't really the direction I wanted to go. But a lot of companies do that. What I wanted to do was to make the UI in Qt, or basically in QML, because I really like working with QML. I think it's a very changeable language for changing UIs, and I wanted something that was super customizable. Because from Opera and from Vivaldi, I knew that changing the UI of a browser can be quite painful. So I wanted to make it in Qt. So I needed an interface to Chromium Blink, and Qt has something called Qt Web Engine, which basically embeds Chromium Blink as a web view in Qt. So you can use it as a QML component, or even like a C++ widget. The problem with that is that Qt only updates it every release, some minor release probably also. So that means probably it skips Chromium releases. Like probably you will, and if you download the latest Qt, you will probably have a 3 to 6 to 12 months old Chromium, which doesn't work if you want to make a real browser. You have to follow the cadence of the project to make sure that you don't have any software vulnerabilities or things in there. And so that was the one thing that I was most worried about. I started so the browser is called Turtle Browser. It's on GitHub. So but what I've been working on mostly is not in that code base as much as I've been working on how to handle Qt and Chromium and make sure that I can follow the cadence. And so this winter, I worked a lot on updating Chromium for various versions to see that I could do it and see that I could compile it for all of the platforms and that it would work. And so a lot of what I've been working on is kind of that bit there. So, but with Qt and with any kind of C++ project, you have building, you have packages that you have to make for all of the different platforms. You have translations that you want to have the system for that. You probably want to have a system for accessibility, for all sorts of things. So the whole thing becomes like so many things that has to have at least the basic functionality of it working. And so that's basically what I've been working on different parts. So my next biggish part is reworking the build system to work with Qt 6, and also to figure out how to handle Qt using Conan, because that's what I'm using for it. And the Qt Conan package moved to the Conan center index, and it's a little bit different, and it's not tested for cute web engine. so, so there's stuff. There's always stuff to do. But basically, it's in itself, building a browser is, given that you have a web view that can like display the internet, it's very much like all other types of applications. Especially if you're using Qt, if you know Qt and you know CMake and you know all of these things, then it's not magic. But if you want to go deep into it, like you want to work on the browser engine, then it becomes, it's a whole world. So yeah, no, so definitely it's there's something in browsers for everyone. So no matter what you're interested in, there's definitely something in there for you.
All right. Well, that sounds like a project you could look into if you are interested to learn more about coding in general and about C++, because you can look into both into the Chromium engine, but also into how to put things together with and kind of bind them for different reasons. Sounds like a very interesting topic. Was this, so working on browsers, was this the thing that prompted you to learn more about security?
Well, kind of the other, yes. Well, yeah, I probably. Although I hadn't really thought about it while I was at Opera, but it was something that I realized when I left Opera and I started to work outside of the browser industry, because I think we all, when we have our first job as programmers, we kind of think, oh, this is what a programming job is like. And I went straight from university to working for a browser company. And even in 2005, which was when I began at Opera, browsers were basically probably one of the most attacked products in the world. And so we had a process for handling security, vulnerability reports, and do security updates, and all sorts of things for finding security vulnerabilities and for testing and doing proof of concepts and all sorts of things. So it became normal for me that was a way that we would work, that we would, I would do crash analysis in an IDAPRO, which is a disassembler. And the way that we worked is how I unconsciously, I think, thought was normal. And so when I left Opera, I realized that most people in the industry don't necessarily think about security much. But for me, that was like, it was normal. And it was something that I think it kind of fascinated me, and I've seen it with a lot of former Opera people working in different other companies. They do have a tendency to think in that way later in other contexts where they are worried about things and want to have systems and processes in place to handle security related issues that other people might find like strange. But I also in the last 4 or 5 years, I also became fascinated with exploitability. So how you can write exploits for native applications, and so I've spent a lot of time digging into that. Although I kind of been dabbling at the edges of this for many years, I wanted to dig further into that, and also further into what parts of C++ and C are vulnerable constructs, and what do they look like, and how can we fix them, and how can we find them. And the tooling for this has gotten much better than it used to be. Today we have sanitizers, we have fuzzers, we have lots of things that wasn't available before, and many ways of finding and fixing these bugs than we used to have. And so I made a training called Insecure C++, which is a 4-day training I've been doing now for several years. and where I basically try to introduce this mindset of looking at code as something that can be exploited by teaching people basic exploitation. So teaching C++ programmers basic exploitation, which is, you could say that like 4 days sounds very short, but these people already know C++. So they're relatively easy to teach. I mean, they understand how a computer works. They understand how the language works. They understand the underlying, abstract machine. They understand, a lot of them can, if you push them, read assembly. And and even write assembly, and they have to in my class. Even though they don't know anything, they can work it out. And so we actually managed to cover quite a lot, and it's very exciting for me to see C++ programmers realize that, this thing that I've always thought of as a bug, that I've seen many times in my career, this can be exploited in this way. And through that exploitation, somebody can actually run arbitrary code on this machine. And I know how to do that. And the moment I think they understand the entire flow, it becomes much easier to reason about and figure out, like, I want to find these bugs. I'm going to change the way I work to find them. So I think I'm basically trying to get people to think in a more of an adversarial way towards their own projects. And I find that very interesting, both from like a teaching standpoint, because I'm fascinated by how much people can learn when they're already C++ programmers. I think the amount of knowledge that C++ programmers have is massive, and we don't even think about it most of the time. But also from a teaching perspective, that you can have that mind shift of going from security, I don't know, that's something that somebody else does, to thinking, oh, I can exploit that application. And that is a massive shift in thinking. So yeah.
Yeah, this sounds like the biggest problem as well from my experience. I've noticed when we do various types of courses or help people, one of the topics that we discuss is also security, typically when we discuss architecture. And there it's even more abstract in a way, because you have to make a few decisions before you actually know. So you have to imagine the threats that are coming against your system. And for some reason, I've been doing this for a while, and I can do it quite naturally. I can figure out threats and come up with all kind of weird ideas on how to break systems. But it's very hard for people indeed to switch to this mindset.
Yes. Yes.
And this seems like an interesting perspective. So what you're doing is actually teaching them how to exploit their own code. So then it becomes easier. It becomes a second nature.
Yeah, that's what I hope. And I also hope that it's fun, because it is fun. And that's unfortunate that exploitation is so much fun, but it is. So it's a part of if you can make it fun, I think it helps with learning. That something is fun, and you feel like, a hacker in the movies. It kind of, I don't know. I think things sticks in a different way than if you just read it in a book.
And I think many people, also from what I noticed, they don't realize that you find, as an attacker, you find like a small crack, and then you find a bigger crack, and then you find a bigger crack, and you keep pushing at it, because typically attackers have time, and these things are mostly automated. It's rarely that you do something specially or specifically for one application, and you can go at it for a long period of time until you reach an actual exploit, let's say, or a big exploit.
And one of the things that I hope to teach in my class, which I think I manage, is that a lot of native applications, so it's like exploitation of C and C++ programs, is very similar to debugging, because we'll be like, a lot of the tools that are used are like the typical tools that we use for debugging application, and so they have already a lot of competency in many of these areas. So the moment they realize that, oh, this isn't so weird, like I can do this. That's also one of the things that I want them to understand, that it isn't magic, and that the people who will attack their applications will be people like them, people with that kind of skill set, and realize that it's that you understand that your adversary in this situation is someone very similar to you, with your kind of background, and you can meet them at a conference. So and I think that makes it less magic.
Yeah, that's how, because we tend to delegate this to security experts, which are
Yeah.
very good. It's very good to have them in the organization. It's
Yeah.
very good to have them try to exploit our systems, but it's not enough.
No.
As a programmer, as an architect, as a tester, you need to also, from time to time, put on this hat of, okay, let's try to break something and see, what kind of information can I get from this system, or what can I do weird that will give me an exploiter.
Yeah. Very much. And also understanding the language that is used, because one of the things that I want to prepare students for is that if they get a vulnerability report, the language in the vulnerability report is going to be using language that is typical for security people, and so they will they won't necessarily understand what these words mean. Like if you get a report, it's like, no, we had a use after free that was exploited to do a heap spray and blah blah, and then people are like, I don't know what this is.
Yeah, so
it's a whole language, right?
Yeah, it's a lot of jargon. Yeah, that's true.
Yeah.
I can't even read some of these.
No.
I don't have that much knowledge to read this kind of exploits. It's more on the general types of threats where we can discuss, and on things like cryptography and so on. By the way, I have to mention this since we got on cryptography. About once a year, I get a person telling me that they want to roll their own cryptographic algorithm because just to be better than other algorithms, and I have to say, never do that.
No, I hear it's like some things should stay as like a hobby project on GitHub. It's like there's nothing wrong with trying to do it to understand it better. Like sometimes you understand something better when you try to do it yourself, and that's fine, but it should stay as a hobby project on Twitter, no, on GitHub, and not go into production. You want to use vetted libraries for real life applications.
So is there one area where you find that the C++ programmers that you come in touch with have more troubles regarding security?
Well, the problem, like if you're looking at vulnerabilities that happen today, a lot of vulnerabilities in C++ applications happen around memory. And that is something that we kind of always knew. It's not like a new problem. All of these memory related bugs, like I mentioned, use after free, but you have like double delete, or you have memory leaks, or use of uninitialized memory. There, a lot of the things that we know are bugs, right? That we've always known are bugs. A lot of them, there are established techniques for exploiting them in different ways. One of the things that I saw the other day, and I also tweeted about it, which was very interesting, was a bug report from Chromium, where they had an implementation of a weak pointer, I believe, and it had a get function that would return the internal pointer in this weak pointer. The problem was that they had an assert that the pointer was not null, but it was a debug assert. So the assert was only on in debug. It's called dcheck in Chromium. But what it turned out was when it was reported that there was a use after free. They had found it using address sanitizer. But when it was debugged, everyone said, but the pointer is null. It has been freed, but the pointer was also set to null pointer. So what is going on here? And the conclusion in the end was that the null pointer dereference that would have had happened in this function was basically optimized away, and the pointer that it used to have was actually returned. So you could have a use after free, and this is because of optimizations in compilers around undefined behavior and such things. But I found that, okay, so this is, okay, sorry, I'm totally nerding out here, but I thought that was super interesting that you had a compiler optimization only happening in release, where a null pointer dereference turned into a use after free, and definitely in that area, it's so hard to reason about C++ and C. That basically, I think we need to move away from manually handling memory and moving to using more things like unique pointer, using our containers properly, move away from new and delete and pointers into more safer constructs and references and values. And that is a culture change, right, for the C++ community I think we still have a long way to go, but you will see it when you look at code that it has known vulnerabilities. Very often it will look like C with classes, and so you can consider that as a warning. If your code base looks like C with classes, maybe you will find vulnerabilities there. Yeah.
So I will come back in a moment to this, but perhaps for our viewers who are not so used to this, what can you do with a use after free pointer?
Well, for exploitation, you mean?
Yeah.
Okay. So there are several ways that you can use this, but probably the most famous way to do this is that if I can get the memory allocator to allocate, as an attacker, allocate that specific piece of memory to me as an attacker, I can fill it with whatever I want to. For example, I can fill it with, let's say that when you use the pointer later, the use after free code, when it uses the pointer, it calls a function. So it takes the pointer and calls the function. Well, as an attacker, at the same address that the address of that function used to be, I'll write the address of my shellcode. So that when the vulnerable code calls that function, instead of calling the function, it will actually jump and execute my exploit instead.
Yeah.
So that's a common way.
So just to give an example, it could do like format everything, or remove things, or send by email stuff to an address, your database backup or whatever you have. So,
yes, install a rootkit. I mean, anything. It's definitely a problem.
Okay, so going back to your to the solution to this, which is stop doing manual memory management in C++. I find it interesting that so I started doing C++ in 2000, and one of the first things, I was working with a team and with a technical lead who was very thorough, and he gave us a bunch of rules to follow, and we had to follow them all the time, and the code was reviewed, and you would often get an angry email that you didn't quite follow the rules, which was a bit annoying, but I learned a lot of things back then, and I've told this story before. But one of the rules was to always use reference as much as possible, reference types.
Yeah.
And I feel that back then reference types, okay, they were still a bit limited. You couldn't do everything with them. You still needed to roll out sometimes your own smart pointer implementation or things like that. But today with STL, at least in STL, you have everything. You have in Boost if you need other things. there's always a solution for you that you
Yes.
can use instead of rolling out your memory. And I wanted to stress that because there are many people, viewers who are also doing C++. So perhaps that's a good
Yes.
advice. Just find out
Yes,
a better
definitely.
way of doing this. Yeah.
Yes, and moving to more modern C++ will suddenly make lots of things available to you that you didn't have before, and will make it possible to rewrite your code in better ways.
Yeah. And I remember, so things like move semantics nowadays, which is
Yes.
something you couldn't do before very easily without
Yes.
pointers and so on. So there's a lot of things that you can replace your manual memory management with.
Yes.
And consequently, perhaps this will reduce your security problems.
Yeah, that's it's probably not good for me that everyone writes better code, because then
I'm sure there will be other things.
No, but I really think that C++ in many ways has a bad reputation for being a language where everything is terrible, and I do hope that through the language evolutions that we've seen, and the improvements in the standard library, that it is much better than it used to be. And a lot of people, you have like bad experiences from like 10 or 15 years ago. And definitely, I just like, people should upgrade to newer C++ versions. They should try to learn modern C++. There is so many good things in the language, and it has improved in many ways. And so I definitely think upgrading and moving on from the terrible past is good.
Yeah, and basically today you can write in C++ programs that kind of look like Java.
Yeah.
It's easier even for people who are coming from Java to try some C++, at least to try, not necessarily to switch to it. But I think the biggest challenge that C++ has is that there are so many code bases and so big. Code bases that are around for 20 years, for 30 years, for 15 years. Almost every team, every C++ team that I work with has this story that they have a code base that's before they were even hired in the company.
Yes.
And so I can understand why it's hard to modernize it, but it's definitely worth it. Okay, so very interesting, because you have an interesting. You started with functional programming, which is already something unique, and then you are interested in security, which is a second quite unique thing for for programmers I'm talking to. It's let me just go back a little and ask you about some of the technical practices that you've been using, and when were you exposed to them? Things like unit testing, refactoring, test-driven development. I don't know if you use it, or when were you first exposed to these practices?
So refactoring and that kind of came in the same time as unit testing, which was I was still at Opera, and so it must have been, I think, like 2000 and I don't know, let's say 7 or 8, I don't know. And it was about like, how could you make things testable, and there was a lot of talk around dependency injection, and to do that, to get to a point where things were testable, and how to do that. And I read Martin Fowler's book. What is it called, about legacy code?
That's Michael Feathers.
Michael Feathers. There you go. Sorry.
Working effectively with legacy code.
Yeah. Yes. It was, and it was an excellent book. And he also came to Oslo and held a talk for the C++ user group in Oslo. about how to do this in C and C++. Like how could you add in scenes in that kind of code base, and he even talked about link time and linking in different libraries for different things. And it was a very it was a great talk. I don't know if he's ever done it publicly, but it was really awesome. And a lot of that at the time, the tooling for C++ when it comes to IDEs and stuff wasn't great. So it was mostly manual refactoring that we would do, and a lot of I think it comes from the book, leaning on the compiler to to figure it out. And also a lot of the testing frameworks were very young for C++ at the time. But also in Opera, and I think in the industry at the time, we had a tendency to always write our own thing for everything. So we had our own bug tracking system. We had our own basically visual diffing tool, and we always made our own thing, our own build system. Yeah, so everything was. It's like you will see that a lot in like C++ companies going back. It's like they have like lots of tools they made themselves. But so it was also very in the infancy when it came to like mocking frameworks and things like that. But it did improve a bit over time. And when I came to, I had an interlude after Opera where I worked as a Java programmer for 2 years. And then I went back to C++ at Cisco. And by then, the tooling had improved somewhat. Like we did have some mocking frameworks and some unit testing frameworks. But still, the IDE situation wasn't great. And the thing is, then I had 2 years with Java. And I think it ruined me for life because they had a JetBrains IntelliJ IDEA. And it was fantastic. I had gone from like coding in Emacs and with a terminal window to IntelliJ, and then going back and sitting there like, where are my tools? And so I was programming mostly I was using Qt Creator a lot, and the number of refactorings in Qt Creator is not fantastic, but it was a massive jump. But now so. At the end of when I was at Cisco, then JetBrains came with the Sea Lion IDE, which I have been attempting to use as my main IDE for basically since then. At Vivaldi, I used a lot of Qt Creator because it's easy to set up with custom build systems. But now I'm basically all of my projects that I work on is CMake based, and I tend to use CLine for everything, and that makes it's not IntelliJ IDEA type of control, but it is better, and it means that it's easier for me to do refactorings needed, and also to set up automated tools. You can just press the play button to run your tests, and you can also integrate it into your build process. So I've been, using GitHub Actions for all they're worth to set up pipelines for my C++ projects. I can use like C tests to run all the tests, and so I think that the tooling for working in a modern way has improved a lot over the years, which makes testing and refactoring much easier to do now than it used to be. Where we just basically, in the old days, where we had a stone and a rock, and it were 2 rocks, and we could bang them together.
Yeah, the project I was telling you about that I worked on, we actually had to write our own unit testing framework.
Yes.
That was the first time that I wrote unit tests, and again, they were all reviewed, so it was a very good learning experience, which informed me all through the career on how to write unit tests that are clean, that are easy to. But I noticed that not many people have this opportunity of learning how to write proper unit tests, and they usually take it as, it's something extra. It's something that we have to do because it's asked of us. Whereas I see it more as, this is how I write code. This is what helps me to make sure that everything is working and I'm not
Yes.
breaking anything and so on. Was it easy for you to adopt unit testing, or was it again a difficult switch?
I think I don't necessarily have the good like test-driven development mindset. I think, and I still don't. I think, but I do. But I have seen many times how unit tests tend to save me, and not so much in the code as I check it in like the first time, but later when I go back and I change something, or if I have to do a refactoring. It is the safety net. Like it's the thing that's going to go, like it's going to beep if something goes wrong. And so, so finding also, I think that we struggled with a while was us finding the right abstraction, both for unit tests, but also for like system tests and for integration tests, and to figure out how to do that. I think we, like as an industry, we spent a lot of time trying to learn. But I have leaned so hard on my tests for so many things. Like if you're gonna go in and make significant changes to a code base that has no tests, it's terrifying. It's just, which is also why you shouldn't do that. You should at least have some scaffolding testing in place before you make changes in the code base. And so I don't think I am like the poster child of test-driven development, but it feels like it's having tests and writing tests is necessary for us to be sure that what we're making is correct and stays correct.
Yeah, I mean, that's always a good message, right? Make sure that you have at least some tests that, because you will make mistakes. I think this is probably one of the hardest things to accept as a programmer.
Yeah.
That you will make mistakes, and
yes.
if you have that in place, you'll find them early. So
yes.
Yeah. Have you ever tried pair programming?
Yes. My first time, that was also at Opera. So this is just when like Agile became a thing. I did not like it. and I think it is because I am quite introverted, and it is a very intensely social experience. And for me, it was exhausting. And I've but I've still done it several times, and I actually think it's easier over video than it is in person. Maybe because I get that a little bit of distance. So I've been doing it a lot lately, over video. But I also did try, that's probably like a year or so ago. I tried mob programming because I was very interested in how that was. And I have to say, I think that was easier for me. And I wouldn't have thought that would be easier, but I think maybe a lot of the intensity of the social interaction that I kind of find difficult as an introvert. I think that was kind of diffused when it was a whole room of people, and it made it easier for me. So I know lots of people that swear by it, and it's like their thing. I think my brain is not wired for it, so I get exhausted very quickly. But again, it depends on the people as well. Like some people, you can go for much longer. So it's I think it's finding a balance and finding a way to pace it, and maybe if there are people very well, you kind of have a flow to it. It's easier. Doing it with new people can be very hard. Just like building up what is okay, how should we communicate. It's a very intensely social thing.
Yeah, That's true, and I think this is one of the things that I recognize personally in agile software development and in many of the, well, in some of the XP practices, which are around more communication, more collaboration, and so on, that introverts, like me actually as well, we tend to lose our energy when we are in these social situations, and you need to have your own space, your own time, your own
Yeah.
separate thing where you can go for a few hours
Yeah.
at least to recharge your batteries or to work on something
Yes.
intensely on your own.
Yeah. Yes.
And this is something that you should recognize in the team, because otherwise it just won't work. It's
Yeah.
so while I like these practices, and the way I've done pair programming is by practicing more and more and more, and it got easier in time.
Yeah.
But yeah, you need to recognize that these are, as you say, very social, very. And this brings us, I think, to some of the more recent developments for you, which is that you have a business and you started growing your team, and you looked at how to organize the business, how to do management, and I think many people are interested in the human part of software development as well. So what have you learned?
What have I learned? I think I've okay. So what I did was what I did as what I usually do. I freak out because I suddenly realize I have to do something I don't know anything about. So I have this, I freak out. The next stage of my freaking out, I read a lot of books, or study or watch YouTube videos, or often all of the above. For a long time, and I spent now a few weeks recently doing this because I freaked out. But one of the things that I realized is that I do have a lot of experience being managed. I have been on the receiving end of management, and I've also had colleagues who were on the receiving end of management, and I have also, so I have observed being like me and others, being on the receiving end of management and still trying to get your job done, and become better and do quality work and be happy and have a family and all of these things that go into having work being a part of your larger life. And so I think I read a lot of these books, but then I kind of went back to myself and to what I know from other people. And we are human beings. And we are in an industry where we use our minds to make things. And that means that our how we feel and how happy we are about things is reflected in what we make. And you have certain things like that are like jokes, like you have, I don't remember what the principle was, where basically the architecture of the program will reflect the organization.
Conway's law.
But yes. Yeah, Conway's law, which is true, unfortunately. But at the same time, I think we sometimes even solve social problems in code, where we will go like, I don't want to work much with this person, so then this person will get the responsibility for this code and I will be over here and we will not touch. And all of these things that we are human beings with brains trying to do what I consider to be creative work through the language of computers. and we are trying to build things in the world, and usually those things that we build are for other human beings, and so we build relationships with those people. Like, we're thinking about what will a person that is using this thing, what will they do? And I don't think that is necessarily something that people who who haven't done the work themselves, that are professional managers, for example, they don't understand how human this is. and they think it's like, go write the code thing and just type on the type thing and do. And so I think what I learned from all of this, reading all the books and looking at my own experience, is that the most important people in a technology company are the people. And that they are human beings who need to feel like they are heard, like they matter, like what they make matters, that it is important, that it is good. In my experience, programmers are not sloppy people. We are people who care about what we make, and we want to do a good job. And enabling people to do a good job makes people more happy. So I guess basically a mind shift from like, we are not managing a factory. We're basically just kind of helping these human beings to be the best they can be. Yeah, so I guess I kind of landed basically at what is I think maybe like what is mentioned in some literature as like a servant leadership, or like an upside down pyramid thing that some people talk about, that basically management is only enabling of the work and not managing the work. And then I think that's also more natural to me, because I've been on the receiving end of management. So
yeah, I recognize this. I think one of the articles where I first learned about this style of management was, I read in 2000 something, so quite an old one. I'm pretty sure I cannot find it anymore, but it was mentioning the kind of Silicon Valley management style and describing it as the managers in Silicon Valley are the people who are pushing away chairs and from the front of the developers, so that all the developers can advance. So you're basically pushing away all the obstacles that they have, and that's the fundamental management style. Yeah, and I think, as you said, as a programmer who is very interested in doing a good job and trying to contribute as well as possible to the thing that you work on, it's great to have something like that. Yeah, that's the kind of management you want. Okay, so we are close to the end, and we like to end starting this year. We introduced a questionnaire, a few questions that we ask all our guests at the end of the conversation. The first, it's 6 questions, so it's not that, and it's not hard. The first question is there a book that you like and would recommend? It doesn't have to be technical, it can be something else.
Oh wow, I have read so many books. Well, recently, I can go with like one of the recent books that I've read. It was very interesting to me. It was called Culture Map. It was one of my many business books, but I think it explained to me a lot of the things that I've been struggling with. I think many times is where I have had a culture difference with someone without actually realizing it was a culture difference. And so in Culture Map, the author, who I now currently don't remember her name, she goes through different aspects of culture and how it impacts work, and impacts cooperation across cultures. And from the beginning, like when I was working at Opera, I was working with people from many different countries, and I worked with people from various countries most of my career. And I suddenly realized some of those issues that had arisen in a workplace was like, that was that thing. That's like, they are like that. And also I think because I've been working a lot with Americans, and I'm from Norway, and I am not very I speak with a very strong like American accent, but I'm not American, and so when I have to communicate with Americans, I can find it very difficult because they do have like a very strong business culture, and a lot of that came out in the book, and I think I'll read it a couple of times, and I think it will help me in working, collaborating with people from many different places in the world. Which is, I think, it's something we're going to do more and more of as we, the world is, people say the world is getting smaller, but we are much more distributed, especially now that we have all of this tooling for video conferencing and for sharing stuff. It's much easier to work quite closely with people, even on the other side of the world. So yeah.
Good pick. Culture differences are fascinating to me. I've also worked with a lot of people, and I've noticed the differences coming from culture, which are absolutely fascinating. Second question, what category of books you don't read too much, and why?
I don't read like true crime or things that are really sad, or things. I think it's like I can read like things. I don't care much if it's violent or not. That's fine. But when it becomes like, somebody harming children or something, that's just not me. So not too realistic. I like to escape. So if I'm doing fiction, I want it to be very different from my life and from my own experience. With technical books, it's a lot of programming stuff. I started my technical career before Stack Overflow, so it means I have bookshelves of books. how we found out stuff in the old days.
Yeah. Third question, what topic do you think is not discussed enough in the industry or in our communities?
I think ethics maybe is something that we haven't really established a good way to talk about. We, like I said before, we make things for human beings. There are human beings on the other side of everything we do, even transitively. And I think we should discuss more the things that we shouldn't build. Like, we shouldn't make this, and figure out ways that we can support each other in saying no to things. Currently there's a movement in the US for creating unions of tech workers, and people say like, yeah, why should you have a union? You get paid so well. But I think unions could be very powerful in creating that solidarity to be able to say no to things that we shouldn't make, that things that would harm other people. And so finding, and I think that is something that we are slowly working out, how to do that. But it's definitely a ways to go still.
Yeah, I agree. There are a lot of things that are part of a profession, actually. So if you look at medics, they have a code of what you can and cannot do. If you look at scientists, there's a lot of discussion around the things that you shouldn't maybe research, even though you could, and so on. And we have indeed not enough of these conversations. Is there a topic that you think it is discussed too much in our industry or communities?
If you had asked me like a few years ago, I would say all of these like silly discussions about like tab versus spaces, or which editor, like VI versus Emacs, But then I said that to someone, and they said, no, these are bonding conversations. And I was like, what are you talking about? No, they are a part of the culture of tech. We have these silly wars over silly things, and it's a part of the culture fabric of programming to do this. And so I don't know, but it's I think and also, but one of the things that I think we still do, which and it's not like we don't do it as a joke as much, is my programming language is better than your programming language, and I don't like that at all. It's like I think all programming languages that are in use today are in use because they found a function in the world that is good for them, and so it isn't necessarily that one programming language is better than another, but that some programming languages fit better for certain problems than other programming languages, and we don't necessarily have to use a hammer for everything. And so and that's one of the things that people ask me, that they want to learn how to program, and they ask me, which programming language should I learn? And I say, okay, so I say, first of all, everyone is going to tell you Python, and you should probably learn Python. But outside of that, and there are two reasons for that. First of all, I think Python is relatively friendly to people, and the second one is we all use Python. Like, no matter what programming language you end up using, if it is JavaScript or if it is Java or if it is C++, we all have some Python stuff. The other language we all have is some JavaScript stuff. Like, all of us have to do JavaScript at some point, and at various points in our career. So some JavaScript and Python are always good, but I think choosing a language based on what you want to build is better. So these are the things I want to build. Okay, what languages are involved in building these things? You should learn those languages so you can make those things. And I think that is worthwhile, because if not, you might get sidetracked into building stuff you're not interested in. So I'm not sure that answered your question, because I forgot what the question was now.
Well, it's a perfect answer. No
Okay.
worries. I think you already answered this one, but let's see. The fifth question: what would be your ultimate career achievement?
Oh, yes. I want to have a browser company. I would absolutely love having like 200 people build a browser together. That would be my ultimate dream. I don't know if that will ever happen, because it's a terrible business model, but and everyone needs to get paid. Like, nobody can do this for free, so we all need to get paid. So, but yeah, if I could have everything I wanted, then I'd probably want to make a browser.
Cool. And the last question: what advice would you give to a younger version of yourself?
It's funny, like when I was at university and I was finished at university, I thought I was finished learning. Like, now you have learned your profession, go out and practice this profession. That was so wrong. That was like so ridiculously wrong. It's amazing how wrong that was. Basically, it's like, now you have learned the basics, go out and learn how to do this thing. And so I think, I don't know if I would, I don't know how to do that. Basically, like, learn everything you can. You're not finished learning. You're going to continue learning for your entire career. I learn things today. I learn things every day. I've been in this business for 16 years now, professionally, after university. So I never stop learning. And I think you have to continue learning, because this business changes. Like we've talked about before, about refactoring and about pair programming and about unit testing, and all these are things that happened while I was in my career, and these things will continue to happen. Like, new things will appear, and you will have to learn those new things. So I think being prepared to continuously learn, I guess, is oh, and one thing that I didn't realize at the time, I was a teacher's assistant at university, and one of the things that I did was I corrected assignments. for other students. So they would hand in their assignments and I would correct them. I did not appreciate this job at all while I was at university. But when I came to work in the industry, this is probably one of the most valuable experiences I had learned at university. Because when I started as a beginner programmer, I had read the code of hundreds of other people. I had to read and try to understand what were they trying to do here, what was the idea they were trying to accomplish, where did it go wrong. I had done this for hundreds of different people that wrote code in different ways, and that made it much easier for me to change other people's code, because I'd already spent so much time reading other people's code. So if I was going to give myself advice, it would be to do more of that, to read other people's code, try to understand it, because that training will make you much better as a programmer, because we do read much more code than we write. Yeah, so probably that.
On that note, a few quick questions to wrap up. Is there anything else that you'd like to tell our audience that we haven't talked about?
I don't know. Like I am on Twitter, so if you have any questions or you want to talk to me about anything, my DMs are open. So just send me a DM or a tweet at me. It's the easiest way to get a hold of me, and that goes for like anything. But besides that, I don't know. No, I don't think so.
Okay, cool. Thank you so much, Patricia, for joining us for this conversation. It's been very interesting. And just to summarize a few points and to link with some other things that we have on the channel, programming is a very humanistic activity. We have a video that's actually named like this, so you should probably watch it if you believe that this is, or at least if you are interested in seeing this other perspective. About expertise and how to grow your expertise, we have an interview with Professor Roger Kneebone, who wrote a book studying various people from various domains on how they build their expertise, and he wrote a book and he published this, and he has a podcast where I was also invited, and we had a conversation on this YouTube channel and a conversation on his podcast. So these are things that perhaps would be interesting to you if you want to grow your expertise in time and keep learning, as Patricia was saying. This is all for now. We have to pay our dues to the YouTube algorithm, so please like, share, subscribe, tell other people about what you found here, write some comments, and let us know in general what you think about this and who else should we bring to the channel. That's all for now. I'd like to thank you all for watching and for your time. I hope you enjoyed this, and until next time, remember to think, design, and work smart.